Sounds good.
Okay, perfect. So today, Lachlan and Kermode is going to talk about damage and quantification data at the threshold of visibility. So Lachlan is a PhD student in the Department of Modern Culture and Media at Brown and a research fellow at the research agency Forensic Architecture at the University of London. After receiving an undergraduate degree in computer science from Princeton University in 2018, he worked for several years as a software researcher at Forensic Architecture, and then as a software engineer building cloud infrastructure for machine learning models. He has also worked as a mobile developer and as a full stack engineer. His current work is concerned with the political potential of open source and open hardware culture, the history of computer science and software engineering as a disciplinary practice, and the implications and impacts of computing as media at large. So, Lachlan, the floor is yours.
Great, thanks so much. And can folks see me on the Zoom as well, or can they only see my slides?
You should be able to see as well.
Okay, great. Okay, I'll get started. So yeah, so I'm just going to talk a little bit today about this research agency that I work with as a research fellow. The research agency's name is Forensic Architecture. We're based at Goldsmiths University in London. And we're a human rights research agency that does open source research documenting violence against people dispossessed by the state. So this includes migrants in the Mediterranean, different communities who are not represented as citizens in any particular national configuration, and various other groups around the world. Our name is Forensic Architecture because the founding method that we use to document these human rights violations is architecture. So a technique that we've come to be known for in the human rights community, at least, is using a 3D scene to stabilize various kinds of footage and forms of photographic and other forms of data evidence to stabilize all of those different perspectives and allow, and the 3D scene works to kind of corroborate the different perspectives. So this image that you see here is a 3D scene that was set up where various different video and photographic perspectives were geolocated within that scene and then used to kind of play the 3D picture of what occurred as it could be known through the media that was available. So this is the architecture in forensic architecture, and the forensic in forensic architecture, I'll talk about kind of at length as we go on. But broadly, what it is designating is that we are looking to do this work forensically, so to work out what happened and what didn't happen, and to represent that to courts of law, international human rights courts and national courts, and also for a broader kind of public domain. So we also show our work in exhibition spaces, as I'll talk to later, and we also publish academic research. So the forensic is specifically talking about the legal meaning and designation of forensic, but we're also interested in showing that evidence more broadly in other domains. Just a couple of examples of the cases that we've worked on. So we've worked on, I think, over 60 or 70 cases now. We've been around since 2010, formally as a research agency. This was one of the cases called Black Friday in Rafah, where the Israeli Defense Force, the IDF, and Hamas had sort of a standoff, and it was very unclear what had happened. So we looked to reconstruct those events using the available photographic and video evidence. I'll skip over that case quickly. This was a case, a more recent case in the UK, which was the killing of Mark Duggan, who was a man who was stopped at in a car by the police and ended up being killed in this kind of like routine stop. We're familiar with the story in American contexts, sort of racialized stop and frisks that end up in killings for one reason or another. And this was a recent case in the UK where we looked to document what had happened as was available from the evidence. I'm not going to get into the specifics of these cases, but if you're interested in them, I encourage you to go and look at those investigations on our website. Architecture was our kind of founding technique, but as architecture, as you've seen, kind of mainly refers to 3D technologies that are used in architectural practice these days to represent space. Software comes into the equation pretty quickly. And my role at Forensic Architecture was as a software researcher, so not trained in architecture at all. I was looking at ways in which we could use software to towards the same kind of political aims that the agency had been using architecture for a long time. So this is an example of one of the cases that I worked on, which was an interactive platform that we put up documenting the cases of police brutality in the recent Black Lives Matter protests. This was kind of like a full stack platform. It didn't involve architecture necessarily in the sense of a 3D scene or the traditional techniques of architecture, but it was the same kind of principles of using what available evidence we had to represent in space and time what had happened. Just this is obviously at a broader scale of across all of America, as opposed to those cases that I mentioned before, which were at the smaller scale of occurring in a sort of constrained time and space. More recently, we've also looked into how this technique can be extended to events and occurrences that are not necessarily, don't lend themselves to obvious representations in time and space. So we were part of a large group of organizations who were investigating the NSO group and their Pegasus software, which has been in the news recently. It's a cyber offensive software that was used to target human rights journalists and other sort of civil actors in various countries. We were looking to document the available evidence, essentially to perform the same thing that I've talked about in the other cases, to use the available media evidence to represent in time and space what had happened and try to forensically reconstruct what had happened. Cyber offensive attacks obviously don't have a clear representation in time and space in the same way that other sorts of violences do, and so we had to come up with this way of representing events in the cyber offensive life cycle, such as malicious text messages and the occurrences that happen physically as a result of those malicious text messages, and also institutionally in terms of actions of civil society and that sort of thing that happened around these events, to show what the real impact and the real violence of these cyber offensive attacks was for the victims who were targeted. So what I'm interested in doing here is talking about why this is relevant to data science and computing in general. Forensic Architecture, as I mentioned, is an architectural research agency, but it's been really instructive for me in terms of thinking about how we can look to use data scientific tools and computing tools through this kind of political framework of thinking about where they came from, where these tools came from, how they're being used in the contemporary world by different actors and institutions with different forms of power, and what we can do to most effectively kind of use those tools towards the kinds of politics that we're interested in. So I'm going to read a little bit here in a kind of more theoretical mode to talk through this idea of forensics, which is the founding kind of principle of this work at Forensic Architecture. And then I'm going to use that to talk about some of our more recent cases, which involve software techniques such as machine learning more specifically, to try to start to think about what this kind of political practice of software might look like. So the term forensis originally pertained to the multidimensional political activity of the Roman Forum, in which citizens would deploy rhetoric and performance to make public claims and commitments. Today, the term refers more readily to the practice of science and medicine in the court of law, the way in which evidence is circulated in order to establish legal and scientific fact. Forensic Architecture, the London-based agency directed by A.L. Weitzman, and where I am a research fellow, was founded in 2010. The project emerged from the framework of Weitzman's book, Hollow Land, a groundbreaking and ground-defining investigation of the spatial regime of the Israeli occupation of Palestinian territories. Using his training in architecture as an analytic technique for understanding built space and the social world, in Hollow Land, Weitzman, quote, unravels Israel's mechanisms of control and its transformations of Palestinian homes into a war zone under constant surveillance, end quote. Hollow Land critiques Israel's spatial statecraft in depth by looking at the physical architecture of its occupation. It was also the seminal instance of forensis in practice, a method that forensic architecture now applies in human rights research and investigations in context across Europe and the world. Forensic architecture's work looks to reinstate forensis as a political practice, and this is the term that I want to work with, forensis. This claim alludes to two important dimensions of our work at forensic architecture that, as I will hopefully make clear in the sections that follow, reflect and rely on each other. The first is making forensis political, and the second is treating forensis as practice.
Sorry, Lachlan.
To say that,
sorry, is it fine that we just see the same slides? It's like a couple of minutes, maybe more that we just look. Okay.
Yeah,
sorry.
it's just on this slide for this section.
Okay.
To say that forensic architecture's work is political means several things. In the first instance, it means that as an investigative agency, we have a politics that is not self-sufficiency or accumulation under capitalism. Modernized forensics, a formulation I take from Weitzman's work in Hollow Land and elsewhere, is the discharge of forensic logic as a supposedly impartial practice, an impartiality that we associate with evidence and fact. When it claims to be impartial, forensics becomes a methodological arm that reinforces and reinscribes state power. To say that a method, field, or practice is impartial is usually to say that it is a practice that traces the grooves of hegemonic power. And we heard about this in Lauren Klein's talk and various others work scholars around data science and computing. To say that your work is not political or is just in the work of how computer science works is to say that it works for how computer science has always worked, which is to reinscribe the grooves of hegemonic power. As a technical agency for hire, practices of modernized forensics have most often served to address claims of the powerful in scientific costume, legitimizing them in society's calculated value system. Part of what it means for us to construct a politics in forensics, therefore, is to work against its dominant modernized conception. Forensic architecture's praxis is political because it turns the forensic toolkit on the state itself, a toolkit that has so often supported violent and dehumanizing agendas of the state. We call this method in this viewpoint at forensic architecture the counter-forensic gaze. By turning the positivistic gaze of forensics on the state itself to appreciate the scope of its activities, sometimes illegal, sometimes violent, we can attempt to demonstrate how the state enacts violence upon and disenfranchises certain people, certain persons and communities by way of those very positivistic terms that the state and other forums over which it has greater control co-opts to legitimize their persecution. A potential effect of turning the state's gaze on itself in this way, and a crucial third dimension of what forensics does as political practice, is the way that an investigation can work to problematize forensics itself as an impartial framework that creates cold, hard facts. So this is where I really want to emphasize starting to apply this framework to computing. To work with, I'll get more into the relationship to computing in a sec. When the state disputes forensic architecture's painstaking, detailed, and precise analysis in courts of law or in the wider world, as they often do, they call into question the positivistic assumptions that cold, hard facts are possible in all cases, and that the state has an exclusive claim to interpreting them. To put this another way, the forensics as politics we do at forensic architecture is conceived no more than simply a project, is conceived, sorry, as more than simply a project of greater representation that seeks to give voice to those that are silenced by the state, which is certainly one thing that we look to do at forensic architecture, right? To give these tools and these methods as a way of articulating violences that are done against groups and communities that wouldn't otherwise have them. But it's not only doing that, it is also, perhaps more fundamentally, I would argue, a critique and performative disavowal of the systematicity of state silencing itself. Forensics as politics often functionally fails as a representative tactic in the courts of law due to how embedded status dominance is in the legal system. So this is maybe some context that is helpful. Our investigations, when submitted to courts of law, are not always accepted for various reasons. Sometimes because they are putting forward narratives and quote unquote facts that the states who control these courts don't want to have to deal with. One example is Israel, who have now outlawed or made impermissible all of our evidence in their national courts. I think that's right. Fact check me on whether that's actually the case, but there are certainly some courts that that no longer accept our work as evidence. The establishment does not accept our version of the facts officially, even when it is painstakingly evident. Even in these cases where it fails legally, however, forensics does additional work in the face of this failure, as the state's refusal of our evidence exposes and problematizes the tight-knit relationship between state dominance and modernized forensic analysis. By demonstrating the distance between convincing forensic analysis and a result in the courtroom, and indeed that the forensic report must always consist of legal and logical cavities for access to every event is mediated, forensics as politics reveals that forensics constructs facts. The notion that facts are pure and unassailable is a deceiving and damaging dissimulation that services those who have the privilege to announce them. So this is really getting at the heart of how facts are constructed, particularly in the legal context, and who has the right to make arguments about what is true. It is for this reason that we call our work counter-forensics. By critiquing the protocols that network the conditions of appearance of forensic fact in the legal forum, we consider ourselves part of a broader effort in the critical geography of legal and political truth. In order to move forward in politics, we first need to map the epistemological landscape of legal representation. Who or what gets to speak, when, and with what authority? More incisively, by what mechanisms and mediations are those outside the frame contained? These questions are crucial to the act of making forensics political, and I think to a serious exercise in politics of any description. So another way of saying that is that in order to think through what a meaningful politics is, we have to be aware of what it can and can't do given the contexts in which it is operating. This sets the scene for the second dimension of reinstating forensics as a political practice, forensics as practice. To formulate forensics as a practice is to uphold that legal determination cannot be reduced or paraphrased as a set of transcoded logical operations. In other words, due process cannot be automated. And this is, I think, really important to critiquing certain software applications in the juridical space. I think a very kind of punchy and easy critique of a lot of these applications that are clearly doing some injustice is that when software is trying to automate due process, it is doing something fundamentally wrong, because due process is about non-automation and considering all of the facts in their full detail. This claim is tied to the stipulation that forensics is as much an aesthetic exercise as it is a scientific one. As Weitzman notes, forensics can never really overcome the complexities of the subject, the ambiguity of language, and the frailty of witness memory. Material science is never conclusive, but subjected to probability calculations and margins of error, and the material reality forensically presented is itself, of course, filtered through language. Forensics is the craft of perceiving and sensing what occurred through examining the forms of representation that it yields. These representative forms, witness, testimony, video, radio, satellite, will always be incomplete to an event's originality. Though it may be possible to deduce strong causality, there is always potentially something lurking beyond the frame, something that these forms of media cannot capture. Put differently, there is always the shadow of a doubt in terms of what data represents. It is for the shadow and this doubt that due process exists in legal proceedings, and that forensics must be conceived as a practice rather than as a determinative machine or a deterministic machine. There needs to exist the victim's opportunity to contest the shadow's cause. One aspect of forensics as practice, therefore, is a specific program to render as transparent as possible those technological operations on whose opacity the state relies. We call this process of forensic architecture aestheticization, a terminology that resonates with the way aesthetics is employed in this context. To aestheticize in a forensic context is to examine the processes by which legal materialities come to be accepted as truth by X-raying the artifacts it produces. To aestheticize is to ask more carefully and extensively, how did these artifacts come to appear in this way? How did what we see on the screen come to be on the screen? What forms of material did it capture? If you followed me in that kind of theoretical turn, it should hopefully be evident that forensics as a political practice has something to offer the discourse on data science and machine learning. Dan McQuillan, an ex-colleague at Goldsmiths, outlines in a text called Algorithmic Paranoia and the Convivial Alternative some of the dangers of the states fraternizing with techniques in big data. The primary data, as McQuillan sees it, is big data's tendency to see correlation without understanding causation. Relying on operations that make mathematical sense, but often overlook the many complexities of what might exist beyond the frame, McQuillan notes that there is a truthiness attributed to machine learning's determinations that is often unwarranted, or at least warrants further investigation. McQuillan sees the dangers that big data can breed as part of a more general belief complex that centers around confidence in the ability to design and operate society in accordance with scientific laws. By putting the oversights of machine learning in touch with high modernism, the terminology that James C. Scott gives to this complex in his book, Seeing Like a State, McQuillan clearly shows that the deployment of machine learning systems in juridical contexts are accelerating the Orwellian cadences of surveillance and technological oversight. So there are hopefully a lot of examples that come to mind in terms of how machine learning systems in juridical contexts are leading to a society that we do not want. Though we might have hoped that historical perspective on World War II, the Soviet Union and Stasi Germany, to name a few, would keep us well clear of such dystopic valence, the emergence of oversighted systems in tandem with the global drift towards the right clearly signifies that at the very least, we must be wary and active in critique of these developments in the present moment. McQuillan articulates in this paper that I mentioned very clearly what is overlooked in the case of machine learning. The primary victim is due process. When machine learning promises to automate juridicality, this motion folds back into the way that juridicality is composed, more and more often short-circuiting due process as a necessary component on the legal motherboard. Algorithmic vision, with all its surveillance, militarized, and operational caprices, becomes the primary way of seeing. What is dangerous about the authority of this technology of vision is that, in McQuillan's words, it is glossing over the lack of its own groundedness. Machine learning operates via an unknown function, that's a quote, that works because it has worked in controlled conditions and not because we understand its determinative processes in a semiotic or representative sense. Exactly by glossing over its own opacity, algorithmic authority derives from this claim to objectivity. In this sense, machine learning oversight works analogously to modernized forensics. Its mechanisms are controlled by the state to reinforce its power and its claims to legitimacy. And I want to be clear here that I'm not saying that machine learning algorithms can't be understood or introspected, but there is no way in which we can say that a machine learning algorithm can do the same thing as a testimony or someone who is speaking to how and why they did what they did in court. There is no way that we can ask an algorithm why it did what it did and understand its motives in a legal and kind of forensic, or in this courtly sense. We can understand it mathematically in various ways in terms of interpretability and this sort of thing, but we cannot use it to replace the idea of due process. McQuillan's critique, however, does not retreat entirely from machine learning as a practice. It simply cedes greater technocratic control to those who already know how they work. A stronger politics than disavowal or retreat in the matter of algorithms is to specifically critique the misguided nature of technological oversight through a careful scrutiny of its mechanisms. McQuillan in this paper calls for a feminist empiricism by way of the work of scholars such as Donna Haraway, and formalizes this method as algorithmic conviviality. Working from McQuillan's thinking on the one hand and Weitzman's on the other, what I propose is that we can also roll a form of practice in the context of machine learning and data science with forensis as an operative concept. By unraveling the groundedness of state and technocratic authority, we can use forensis as a political practice to counter algorithmic vision. My proposal is that we need more forensis in the context of machine learning, data science, and computing infrastructure at large. So with that sort of theoretical backdrop underway, which is hopefully useful to some, I want to talk about some of the work that we have actually done using this kind of this framework and this concept of using machine learning and data science, but doing it with an attention to what it can say, what it can't say, and how it can and can't work towards the politics that we want to see in the human rights space. So a very topical investigation at the moment was, because of what just happened in the news, this was an investigation called the Battle of Ilevice that was about a skirmish in 2014 in Western Ukraine, in which Ukrainian nationalists were trying to take back a city from Russian-backed rebels. And when they tried to take back that city, essentially Russian tanks came in from across the border and kept them from taking back that city. So there's been lots of varying forms of evidence of Russia backing these rebels in Eastern Ukraine, sorry. But this was one of the clearest kind of examples of when Russia provided clear military assistance in the form of a column of 100+ tanks, basically, to keep Ukrainian nationalists from taking back this region. So this was kind of broadly known in human rights communities, but we wanted to document it and make it more systematically available, all of this evidence for proceedings in court. So when okay, cool. It's just a slight delay. When I say this was broadly known, I mean that there have been a number of human rights groups who had done open source investigations documenting all of the evidence of tanks in Russia at this time. This was also at a time where some of you who follow these events may know Russian soldiers used to post on social media pictures of them in certain parts of Ukraine, which would identify them as being actively in service in parts of Ukraine. And human rights groups and agencies would find those images and use them as evidence of the fact that there was Russian military presence in Eastern Ukraine. So there have been a number of investigations that have been done that focused on certain images and videos around the web to show that this was the case. But there was also a potential for lots of other videos that people had uploaded to YouTube, this kind of whole potential space of the public domain, where we could find evidence or more evidence for military presence in Eastern Ukraine during the series of events, which is what we were interested in showing in this investigation. So for those of you who work in image detection or computer vision, you might know that this is kind of a good problem for computer vision to try to solve, in the sense that what we're interested in doing is taking the public domain media space, which is potentially quite large, and triaging it for images that might contain, in this case, we were very focused on tanks, particularly because there was a particular type of tank, the B-72T3, that we knew at this time was only manufactured in Russia and had not been exported to other countries. And so the existence of this tank in Eastern Ukraine was a pretty good signifier of Russian military presence at this time. So we wanted to try to find as many images of these tanks in this context as possible. I'll skip that slide because this is talking about how machine vision works, but I think we can gloss over that. So we developed this interface essentially, which was a workflow that allowed journalists and human rights researchers to do the same sort of thing that, you know, data scientists might be able to do by whipping together some scripts. They could choose a classifier, they could choose a context in which they wanted that classifier to run, and they could choose a media space, broadly defined as a set of search terms in a particular period, and they could then run that classifier over these search terms, over the images and videos that were returned from the search terms media space. And what they will get back is an interface that looked like this, where each cell, each sort of square gray rectangle there represents the video, and the duration of the video is from left to right, and the red marks along the timeline are frames in which the classifier has identified that there is potentially a tank of interest in that section. We can then order these videos, so we can run this across a number of videos, and then we can show these results to human rights researchers and journalists using this as a kind of heuristic to narrow down the amount of videos that we need to look through. You'll notice that we didn't, in this case, try to solve the problem entirely through machine vision, because there are lots of ambiguities in machine vision and the identification of particular tanks. The approach here was not, we need to train the perfect classifier that can, in all cases, or in a majority of cases, sort T-72B3 tanks from other tanks in an arbitrarily large public domain media space. One, because that, at least at this time, was not easy problem that we could kind of take an algorithm off the shelf to do, but two, because it would go against the principles of what I was talking about understanding the limits of machine vision in the work and labor of due process. So in this case, we wanted to present a platform where we were making an argument about all of the evidence in that platform as being evidence of Russian military presence in Eastern Ukraine. Automating the collection and the appearance of videos in that platform is against the principles of this kind of this interpretive labor of working out whether or not this image could be argued as being relevant to these events or not. And so what we did with machine learning and data science here was provide a platform to allow them to triage the public domain media space better and hopefully get images and videos more quickly, but not try to automate beyond that, not try to automate the actual interpretive labor of looking through these videos, working out whether there is anything, forensically speaking, that could relate these images to the context in which we were interested, and doing that work due process. This is what the platform looked like. It's available online, and it showed a number of events, some of which were sourced through this process that I explained before, but some of which were sourced also just through more quote unquote traditional modes in open source research. So journalists and human rights researchers who understand the space, going to different platforms, looking through it and trying to find different images and media that might be relevant to the case, following leads that they know from understanding the space and this sort of thing. This is kind of an aside, but this platform came with a bunch of open source technologies. The database for the platform is a Google Sheet, and we decided on that setup because the journalists and human rights researchers that we were working with don't want to enter things into an SQL database via a command. We don't want to have a data scientist in the middle who has to import things. We don't want to make a custom UI so that they can update this data. People in the human rights space know very well how to work with Google Sheets, and what we wanted to allow them to do that while also allowing us to have a well-formatted data structure. And so we created this front-end technology called Time Map, which is that interactive cartographic map that I mentioned, which consumes a set of events and represents them in time and space with a timeline and on a cartographic backdrop. This, oops, sorry, went one too far. This back-end technology, I guess, that we call data sheet server, which is basically a shim to a Google Sheet that then allows the data in that Google Sheet to serve as a back-end. The reason that this is more desirable than just pulling directly from the Google Sheet is that we had lots of people who were editing the Google Sheet, and if one person goes in and breaks a cell or does something wrong, then it's going to break the whole platform, which is obviously not the ideal. So this is kind of like a validation layer and also a data management layer where we can make sure that all of the data is going to work, drop the data that's not going to work, but not do any more than that in terms of dictating how researchers enter that data. The data is all still coming directly from the Google Sheet, and when we update the platform, we update the Google Sheet, and then we click a button on this interface basically. And Clive framework for orchestrating the download and analysis of media. So this was basically how we deployed the classifiers in that interface that I mentioned before. This is basically a Python Clive application with some container management stuff to run classifiers at scale and parallel, not on the cloud, because in this particular case, we were not interested in doing that for legal reasons, but on a single device or multiple device.
Sorry, Lachlan, I think that we are really out of
sorry.
time. Yeah.
Over time, sorry. So I'll stop there, and thank you for your attention.
Thank you. So if there are any questions, I think that Lachlan would be happy to answer them. Otherwise, I can go ahead. Actually, so the first thing that I'd like to ask you, it's more around data. First of all, the talk was really interesting. Sorry, and I wanted to ask you a clarification that maybe I lost through while you were talking about how the images were collected, if they were from social media or they were from social media from news outlets. So this is the first question. And then I was curious to understand whether you envision in the future the possibility of automatizing this kind of production of interesting data information for a generalized for any topic. So whether you think that might be a way to automatize the process of retrieving images for a specific topic and then immediately train. I guess that the models you used were fine-tuned on your data, whether you think it might be possible to automatize the fine-tuning of the models and then their deployment within such platforms.
Sure, yeah, so to the first question about where the data was coming from. So the data was basically, as a prerequisite of the platform that we were building, was what in the journalist space is called open source data, which basically means public domain data. So data that was we didn't have any privileged access to data sources. It was data that was available on YouTube, data that was available on Twitter, and that we could find through those APIs or interfaces. There's obviously a lot of data loss on those platforms, and so once we had found a certain image or video, then we would archive it in our own servers so that and keep a reference to it so that we could still count it as evidence, even if the original link had gone down. To the second question about
sorry, before you move on, sorry, just to not get back again. There was the last, I think the last couple of slides where there was the geolocation I guess, of the so I was wondering how you get this georeferenciation, whether they were in the images you got, or you do some inference from the context of the video or the image.
Yeah, so the georeferencing is not automated in the sense that it is, you know, we work out where that image or that video is based on manual interpretation. Basically, the data is, you know, scrubbed from the geolocation data is often scrubbed from those platforms. And so when we could use the geolocation data, we would use it to potentially assist our interpretation of where it occurred. But we always wanted to double check that that image and that video sort of matched the surroundings. So that was where the architectural techniques that I talked about earlier came into play. If you look at the videos that we have for this investigation on our website, you'll see more detail about how exactly that geolocation took place and how we used certain reference points in the images and that kind of thing to work out where these images were to the best of our ability. Just quickly to address your second point about automation. So I think that I didn't get to talk about the other ways that we've extended this method in future investigations and current investigations. But the question of working out what it is you're looking for in order to service the investigation from a human rights perspective is not the sort of thing that can be automated. So in this case, we had tank equals potential military presence in Eastern Ukraine, and that was kind of a clear correlation. But in every investigation, I think we need to work out what we can do within the constraints of current technologies, current recognition technologies, and what we can find and what we potentially can't find, and how closely that is correlated to the legal question that we're interested in, or the question of finding some sort of thing. So that work, I think, cannot be automated. And as a result, there are definitely parts of the pipeline and the process that we can automate in terms of training algorithms in certain contexts and trying first passes and that kind of thing. But like many other data science applications, it's still very kind of early stages in terms of working out how to firm that up. And we're more interested in making sure we have the right questions than we are in trying to prematurely automate parts of the process.
Thank you. Thank you. Again, it was really interesting.
Thanks. I think Shahrazad has a question here or a comment.
Sorry, I'm just going. So as I understand, you provide this information to independent journalists, something like that. Is there any other research beyond that, or?
What do you mean by independent journalists? Sorry.
What is the goal of your activity? I mean, I understand the principles, but in practice, do you work with journalists, do you work with governments? How do you use this information?
Yeah, so we don't work with governments, as I've probably got to be more clear about that as part of what I was talking about in the theoretical section where I was talking about the state. Yeah. We as an agency have a mandate to not work with governments, and we only work with groups who are having violence done against them by some sort of state or state-like entity. So we have a strong kind of political prerequisite for any of our investigations in that sense. In terms of journalists and that sort of thing that we work with, this investigation was with a legal firm who were looking to make a case to a court of human rights and wanted this evidence to back up their arguments. So often we work with partner organizations towards their goals, but we also made this platform publicly available as a reference for anyone doing research in this space. And in the case of technologies that we created, we published a paper about NeurIPS about some of these things, and we obviously made those things open source as well. So there's kind of multiple places in which we're looking to have an effect with this work. It's not tied to a single specific context. Yeah, it depends by what you mean by ourselves, in the sense that there are lots of other human rights organizations who work in the same context. Bellingcat is one that comes to mind, especially in the work of documenting Russia and that context that I explained. They do a lot of great work and did a lot of the original work in this. Groups who use like architecture, in some senses there are. The New York Times has a visual investigations unit that in some senses is similar to the work that we do. And there's some, people who have worked with us who have then gone to work there and so on. So there are multiple groups who we work with, and it's kind of like a collaborative enterprise. If that answers your question. Yeah.
Okay, so thank you again, Lachlan. I think we can move on with our next speaker.